right, good evening once again, everyone. As you can see on the title, the title of this class is Data Viz with Matplotlib. That is actually data visualization in full with Matplotlib. So today we'll be introducing Matplotlib to us. We rounded up with pandas in yesterday's class. The video has been uploaded on YouTube for us. Also, the materials, some new materials were posted just a few minutes ago. So if you check the Google Classroom, you're going to see some materials that were posted. The material for today has also been uploaded on the Google Classroom. You can follow along with the class by downloading the material. The data set also that we used for yesterday's class has also been uploaded as well. So everything you need to follow up with the class is available. You just have to go to the classroom and download what you need. All right. So today we go. I think another thing that I missed. I uploaded a cheat sheet for pandas. All right. So there's something called cheat sheet. I uploaded it. You can just check it out. It's kind of like a summary. So it's like a summary of the relevant functions you're going to be using most of the time when using pandas. So I think I would have to share that so you can see what I mean. Just give me a minute. All right. Okay, I'm going to share my screen now. All right, so if you see my screen, you're going to see the cheat sheet I shared with us on the Google Classroom. So it's basically a 2-page PDF, right, containing a lot of functions that you're going to be using in Panda. So it's a summary, basically, something you can just reference, let's say, while you are working in Pandas, right? You can also always look at it to just give you a glimpse of the commonly used functions in pandas. I think I also have the NumPy cheat sheet, which I'm also going to upload as well. So you can use it as reference. So you can see here that we have functions on creating data frames. You can see the pd.data frame. You can see it also like represented in tabular form in visualization as well, right? So you can see a lot of things, even some things that we did not discuss. You can see the reshaping of data set here, how it is represented in a diagram form. Also some cool functions that we didn't touch. As I said, there are a lot of functions in pandas, all right? So you can see some other ones we have here. Just keep me okay. Then some other ones we have here, drop, duplicate, sample, n largest, n smallest, head, tail, a lot of things, right? You can see them here. So I encourage you to go through this cheat sheet. You're going to learn a lot. You can just look at and the explanation, quick explanation is there as well. So see all these things here. You can see getting accessing rows using iLock and lock, and also iArt and also add. So this also is a function that can be used to access values. And you also have the query function as well. df.query, you can use it to query. Query basically mean getting a particular is like filtering, basically the same thing we did before, but this one is more refined. Using df.query function. So if you see it here, you can see how it is being used, right? You use the conditional statement in the brackets here straight away, right? It is cleaner than using the other method that we showed you. But if you the thing you need to know is how to query or how to filter your data set, and the one I showed us or taught us is the most basic way of doing that. So if you know that, you can as well just adapt it to any other function, right, that we have. So as I said, as I've said repeatedly, there are several ways to do the same thing in Python, all right? So if you can do something in in Python using a particular function, trust me, there's another way, there's another option to do that same thing. So that is basically what you're saying here. So I won't be able to go through all of this, but I encourage you to just go through them yourself. You are going to actually learn a lot. You're going to actually, you can see a lot of things here. You can see this assign, drop NA, fill NA. You can see a lot of things basically. So please, the material is available on the Google Classroom. You can download it and play around with it. I will also make available the NumPy cheat sheet as well. I think we have the NumPy cheat sheet. So yeah, as you can see on the screen here, these are the NumPy operations that are commonly used as well. So I think I'll also make that available after this class. All right. So I just wanted to bring that notice that it has been uploaded on the Google Classroom. So do well to check it out. So that is it for that. Let's go straight to what we have for today. All right. So can everyone see my screen and can you hear me clearly? Please let me know. Let me know. All right. So the attendance for today will be posted by the class rep. It will be posted by 6:30. All right. So that is 1 hour into the class. It will be dropped by the link for the attendance will be dropped by 6:30. So just look out for it on the attendance group chat. So the class rep is going to post that, and you do your parts by filling in your names and doing the necessary thing. All right. Yeah, I'm going to zoom in. I just want to be sure that we can see the screen. Okay. All right. So today we'll be looking at data visualization with Matplotlib. All right. So what we will be doing basically today is I will be introducing us to I'll just give us an overview, a general overview of what data visualization is, the essence of data visualization, and then we're going to move into Matplotlib. All right, using Matplotlib to plot charts and graphs and basically just do data visualization in Python. All right, so Matplotlib is another library that we will be introducing today specifically for data visualization. All right, so this is not an extensive course on data visualization, but just a quick one to give you an idea and a good ground so that you can build up from there as we're moving forward. Because most things you are going to be doing in data science would involve you using Matplotlib, right? Because you always want to represent what you are doing in visuals, all right? Very, very important. So as we all know that the picture is like 1,000 words, right? So it's something that you would use a lot of numbers to describe. You can as well just use a single chart to explain that in a very clear and concise, straight to the point manner. So we're going to be looking at the importance of visualization and so many other things, and then go straight to how we can implement and use Matplotlib for visualization. All right. So let's move ahead. I hope we're able to round up with this today. So we'll pick up with machine learning from next class. But if we're not able to round up, then we're just going to round up next week Saturday and just start with machine learning. All right. So now let's quickly look at what we have for today. So we're going to introduce data visualization, then talk about the common data visualization techniques, and then look at Matplotlib. I will introduce Matplotlib to us and also talk about the core concepts in Matplotlib, and then we'll move into using Matplotlib for data visualization. All right, so we'll look at how we can use Matplotlib to plot several charts in Python. All right, so it's going to be an interesting one. So please just pay attention. All right, it's not going to be it's not going to be very complex as what we were doing previously. So you just need to understand how to use some certain functions, all right, and understand the basics of Matplotlib. So let's just move on. Let's move on. All right. So today we are looking at data visualization. So what exactly is data visualization? I want to believe that this is not our first time of hearing this phrase, this word combination, data visualization. All right. Even if you are not familiar with data visualization, you should know what visualization is. All right. So visualization is something you can see or something that is represented in a graphical format. That is what visualization is. So we can have a lot of visualization that are actually not based on data. All right. But when we have a visualization that was adapted, or there's a representation, or there's a representation of a certain data type, then you would. Sorry for that. Okay, so basically, visualization is when you want to represent, when you're representing something in a graphical format for easier understanding. But data visualization is when you are introducing data, or when you are trying to represent that data in a visual aspect or in a visual format. So you can see that what we've been doing over the weeks is basically just looking at different data, right? Whether being something that we generated ourselves or the data set that we used yesterday, we've just been looking at numbers. So those numbers we are looking at, we can actually transform them into visual representations, right? And that is what we call data visualization, an act of representing an information, right, that we've gotten from our data in a graphical format to make it easier to understand, analyze, and communicate trends, patterns, and relationships within data. So there are a lot of things that can be achieved with data visualization, right? So we can categorize them into two generally, all right? So data visualization can be used for exploratory purposes, all right. Exploratory purposes is basically you want to just understand your data. You want to know how the shape of your data. You want to just understand the general pattern that is in your data. So that is for exploratory purpose. So when you are doing EDA, when you are doing exploratory data analysis, data visualization is a core aspect of EDA. All right. So it helps you to gain intuition about your data as quick as possible. All right. So you don't just rely on seeing numbers and all of those things that we did yesterday. So you can actually represent those things in visual format to give you a better understanding of your data. So exploratory data analysis, exploration is an aspect that we can use data visualization for. The second one is descriptive analysis. All right. So we can use our data to describe some certain things. All right. Um, we can use data to describe some certain things. Please just give me a minute here. All right. So basically, the other one is descriptive analysis. So you let's say you want to represent some information that your you want to represent your some information that your stakeholder or your boss has asked you to represent or to generate. You can use, instead of bringing numbers to them and using the numbers to explain what the insight you've gotten, you can basically use the data visualization to convey the information to them, right? So it might be anybody, it might be maybe a client, it might be stakeholders, right, in a company, it might be your boss, or just basically anybody that has requested the data visualization. So you normally, or you probably have seen a board meeting, all right? You can just visualize a board meeting where you have several stakeholders, CEOs, and all those top people in the company, and you have someone standing at the front with a screen, and in that screen there are visualizations, right? There are line charts, there are bar charts, there are a lot of things there. So that person is almost likely going to be the data analyst, all right? The person is using visualization to explain the insights that they got from the analysis they've done. So it might be insight regarding the company's growth or the company's sales performance. So instead of using numbers to just explain all those insights, they can easily use visualization to showcase what they've gotten. And it is easier for people that are not data analysts or data scientists to understand those insights better when they see the visuals, all right? That is why you see a lot of visuals as the end product of data analysis, because most people understand pictures. Human beings generally understand pictures better than numbers. So that is why a lot of effort is being put into data visualization, all right? So those are the two major use of data visualization. We use it for exploration during our analysis, and we also use it for to also convey information, all right? Convey our findings, right, to the stakeholders, clients, or our audience. So basically, that is what we use data visualization for. It's as you can see here, it transforms raw numbers into visual elements like charts, graphs, and maps, allowing human perception to grasp insights that might be difficult to glean from tables or spreadsheet alone. So if someone give you two options, right, that which one is more intuitive or which one is easier to understand, a spreadsheet that has rows and column of different descriptive statistics of variables, all right, or different analysis results, or a visual that basically shows you or represent that same information. The one you're likely going to choose is going to be the visual, because it's intuitive, like it is easy for you to grasp something, to understand something that is visually represented, right, than something that is represented in numbers. So that is basically how we are aligned as human beings. So data visualization is very, very important. Okay, let's just go ahead and look at the benefits of data visualizations. So we have several benefits of data visualizations. The first one here is enhanced understanding. All right. As I said, visualizations simplify complex data, making it easier to identify patterns, trends, and relationships. All right. So it enhances understanding of our data. So the next one is improved communication. As I've said, clear visuals effectively communicate insights to a broader audience, even those less comfortable with raw data. So these are the things I've already explained. So with visuals, you are able to easier communicate your findings to audience that might not be data inclined. All right. That's a benefit or an importance of data visualizations. The third one here is informed decision making. Visualized data empowers decision makers with a clearer picture, leading to more informed choices. So you see most of your CEOs, most of the managers, and all these top people, what they work with mostly are visuals. All right, most of the time they work with visuals because they just want to see the trend. They want to see they want to have a clear understanding, a very clear picture of what is happening. So visuals is a way to kind of lead them in that direction. So it helps in informing the decision making capability of businesses, right? So the last one we have here is data exploration. As I've said already, Visual exploration can reveal unexpected trends and patterns that might be missed in textual analysis. So sometimes if you are just relying on raw numbers, right, to gain insight, you might miss some things, right? So those things are better represented or better captured when represented in visuals. Just like outliers, right? If you are told to determine if your data has an outlier, it might be difficult for you to just know that basically or by just looking at the raw data. But when you represent it in a visual form, you'd most likely capture that, right? So either with box plot or scatter plot, you can easily get the outlier from a data set and know if the data set has outliers. So those are the benefits of data visualization. So you can now see how important data visualization is in data science and data analysis. So let's just move ahead to common data visualization techniques. So now we're going to be looking at some visualization techniques that are being used, right? And all these techniques, we're going to look at them one after the other, and we're also going to demonstrate them. So this we have two parts for this lecture. Today's lecture, the first part is just explaining visualization and all these things that I'm going to be explaining. After I'm done explaining, then we'll move to the practical aspect where I'm going to show us how to do all these things in Python. So it's better, it's good you understand this particular aspect. So when I am doing it, it just helps. It's easier for you to understand what we are doing. All right. So let's just move ahead. So we have several visualization techniques, and we're going to look at them one after the other. So the first one we have here is called line chart. I don't know how many of us have seen line chart before, but if you've seen a line chart before, please let me know in the group chat. Like just say yes, I have. Like let me just know how many of us are familiar with line chart here. Okay. All right. So that's nice to see. So it's not something that is new to a lot of us. So plenty of us here, we've seen line chart. Either we've interacted with it directly or we've seen it from an external source. All right. So it's a very, very common data visualization technique. All right. And all these visualization technique, they serve different purposes. Let me repeat that again. Visualization techniques or charts and graphs, they serve different purposes. You cannot use line chart for something you're supposed to use bar chart for. You cannot use bar chart for something you're supposed to use scatter plot for. You cannot use scatter plot for something you are supposed to use histogram for, and vice versa. So you have to understand when and where to apply all these visualization techniques that I'm going to be mentioning. So very, very important to note, because I see some persons after learning about data visualization, they go ahead to misapply these techniques. All right, so it's very, very important that you know how to accurately and appropriately apply these several visualization techniques. All right, so the first one here is line chart, and line chart is ideal for showing trends or changes over time. Now, very, very important. Whenever you're talking about time, as long as time is involved, line chart is the best chart to use. I will say it again. As long as time is involved, line chart is the best chart to use. So time can be in any unit. Time can be in seconds, right? Time can be in minutes. Time can be in hours. Time can be in days. Time can be in weeks. Time can be in months. Time can also be in year. All right. So any form of time representation you have, as long as it is a time variable, use line charts. I'm going to say it again. As long as it has to do with time, use line chart. So basically, line chart just shows a trend over time. So as something is as a particular variable, let's say you want to measure your sales over months across the months in a particular year. You want to measure the sales the amount of sales you've made each month. The best thing to use is to use your time chart, your line chart rather. So basically in your y-axis, you would have you have your number of sales variable, and your x-axis you have your time. So your x-axis is always the time, all right? So basically how you do it, you would see that there will be different points that will be plotted across time. So for October or for January, you have a value, right? For November and February, you have a value. March, you have a value, and so on and so forth. So once you're able to get the value for each of these months, you can now plot that line connecting the different values, right? So from the line you plotted, you can now see the trend. You can now see the particular point that is the highest. So from just mere looking at the line, you can know the month that had the highest sale, and you can know the month that had the lowest sale, and you can know the trend as it's going. You can know if the sales were increasing as the month as you were moving across the months, right? Or maybe during the middle of the year you had a higher sale, or maybe during December the sales, the number of sales was increased drastically because of it is the season, December season, all right? So these are the things that you can glean from line charts. So whenever it involves time, just know that line chart is the ideal chart to use. So we're going to demonstrate that today. You're going to see how we will use line chart, all right? So let's just go ahead. We have bar charts. So bar chart is like the most popular chart that that is being used in data visualization. Basically, bar chart is effective for comparing categories. So when you have categorical data, the best chart to use is bar charts, all right? So your bar chart can either be horizontal. Let me zoom out so you can see everything. So your bar chart can either be horizontally inclined, right, or vertically inclined. So the bar in this case is vertically inclined, right? But if it is horizontally inclined, it will be inverted. It will be coming from left to right, all right? So we have two different orientations, but basically they are both known as bar charts, all right? So each bar represents a category, a distinct category. So if for that variable you have 4 categories, in your bar chart you would have just 4 bars. If you have 10 categories in your bar chart, you have just 10 bars. So when it comes to categorical data, you make sure that you use your bar charts, right? So we're going to look at how to do this bar chart in Matplotlib, and you can actually also perform bivariate analysis with your bar chart. You can perform univariate analysis by just representing only a single variable, right? So what is going to be on your y-axis will be the count or frequency of each category, all right? But if you are doing bivariate analysis, then your y-axis will represent the other variable that you are comparing with the category. Let's say you want to compare the prices, as we did yesterday, of the different product categories. Your y-axis will be the price value, your x-axis will be the category. So it's going to be plotted in a way that the length of the bars will be equivalent to the height of the bar rather will be equivalent to the price of the average price of that category. Do you understand? So basically that is how we apply bar chart or use bar chart in plotting. So the next one we have here is scatter plot. All right. So scatter is a very popular chart as well. It is used for numerical variable. All right. It is used for numerical variable. We've seen line chart. Line chart, we said it is used for variables, time variables. All right. Bar chart is used for categorical variables. It can be either univariate, where you are just trying to know the frequencies of each category, or bivariate analysis, when you want to compare the categorical variable against another numerical variable. Do you understand? So the next one we have here is scatter plot. Scatter plot is used for numerical variables. This is, we did correlation yesterday, right? We talked about negative correlation and what? Positive correlation. So we were just talking about it, but scatter plot is what we use to visualize that correlation. You understand? So this is the visual representation of what? Correlation. So in this case now, I'm just going to explain the what how I'm just going to show you how to interpret the scatter plot, right? A scatter plot has the same thing with other charts. It has x-axis and y-axis, all right? So the x-axis and y-axis are two numerical variables. For example, it might be your price and quantity, all right? So they are used, scatter plot is used strictly for numerical variables. So what happens is that these two variables are plotted against each other, and for each data point, you have a dot. So each dot is plotted at the intersection of the two variables. So when all the observations are plotted, you are going to get a plot with different plots. So that is scattered all over the plot. That's why it's called scatter plot. So we are going to have this kind of representation. And the direction of this scatter plot determine the correlation or the correlation strength of the two variables. So in this case now, you can see that the direction is upward. We are seeing, if you look at it, you can actually draw a line that is going up from here. So this is indicating a positive correlation, all right, that these two variables are positively correlated. They are strongly positively correlated. So you might not actually get a value to tell you the exact, you will not get the value to give you the specific strength of the correlation, but you can see it visually that, okay, there's actually a relationship between these two variables, all right? So scatter plot is used in line with correlation value. So when you get the correlation, you can just look at it, just visualize it, right? Just to see the strength of the relationship. So in this case, we have a correlation, but in a case where there is no like direction, everything is just scattered everywhere, you can say that there is no correlation at all between the two variables, right? So there's another case where if instead of it going from left to right, it is coming from up like this, coming from up to down, right? The same direction, but from up here to down. That is a negative correlation, all right? That is a negative correlation. So scatter plot gives you that visual representation of correlation between two numerical variables, all right? So let's just forge ahead. So the next one we have here is pie chart. So pie chart is like another very popular chart that is being used in visualization. So basically, pie chart is for categorical data as well. So when you want to understand the same way you use your bar chart is the same way you use your pie chart. So I don't need to explain so much about that. All right. So I just want to mention something. Please don't abuse pie chart. If your category is more than 5, please don't use pie chart. Just go ahead and use your bar chart. All right. So pie chart is best suited for just maybe a small number of categories. Let's say you have 3 to 4 categories, or let's say at most 5, right? You are okay with it. So if it exceeds 5, you are better off using bar chart than pie chart. All right. So this is another data visualization technique or chart that is being used, right, to represent your data. So we're going to also see how we can do that. So the next one we have here is what? Histogram. All right. Histogram. So histogram is another data visualization technique, right? That is used to understand the distribution of your data. So this is a statistical concept, right? This is a statistical chart, basically, right? There's what we call normal distribution. So most of the numerical values you have or we have are usually normally distributed. So for you to perform some statistical analysis on that data, they need to meet that assumption of normal distribution. So when we get to machine learning aspect, you see that we have a lot of assumptions before selecting a particular machine learning algorithm. So one of the assumptions is that your data has to be normally distributed. So this histogram that we have here is a chart that would tell you if your data is normally distributed or not. All right. So this is one of the charts that shows the distribution of your data. It is used for numerical data. This is not bar chart. Some of you might be saying, okay, this is similar. This is not bar chart. Bar chart is used for categorical data. You can see that there are spaces in between the bars here. All right. In this histogram, there are no space. There's no space here. All the bars are joined together. And these bars, they are not called bars. They are called bin. B-I-N, bin. Right? And in Matplotlib, you can actually set the bin size. So we're going to demonstrate all these things once we start the demonstration. All right. So basically, this is our histogram, which is used to reveal, as you can see here, the distribution of data, right, within a specific range. So it is for numerical variable only, for numerical variable. All right. So we have our heat map here. All right, we have our heat map. This heat map is basically we're not going to demonstrate it today, but as we are proceeding, you're going to see how we can apply it in several things. It's basically for correlation analysis. All right, when you want to get the correlation of several variables, you can use this heat map. So while doing our machine learning, we're going to demonstrate how to use heat maps. All right, so you're going to see that there's another visualization that I did not include here. It is called box plot. So it is called box plot. So how many of us have heard of box plot before? I mean, it's not a very popular visualization. I'm going to, let me see if I can get a picture. All right. Just let me see if I can just get an image of the box plot. All right. So we can see this particular visual here. This is a box plot. This is what a box plot looks like. All right. Now this is I think the most complex visualization that you might come across. Like if this is your first time of seeing it, you'll be very confused. Like what exactly is this? Like I think visualization are supposed to be are supposed to make things easier to understand, but this one is even making it more complex, right? But actually it is not complex. There's a reason why we have all these things happening. So the full name is box and whiskers plots. All right, box and whiskers plot. So what we have here is we have the whiskers. So this thing that is extending from the box is called the whiskers, right? And this rectangular box here is the box. Okay, so everything here has interpretations. Like from this particular particular line that that is at the lower end of the whisker, corresponds to the minimum value in your data set. All right. It corresponds to the minimum value. Why this one up here corresponds to the maximum value. So this is also showing the distribution of your data as well. And now the most important use of box plot is for outlier, for the detecting outlier. So when you plot your box plot, every okay, box plot is for numerical variable. Let me just say that so you would not get confused. So when you plot your box plot and you see any dot outside these whiskers, like outside these whiskers, right? You would see them maybe if you are working with box plot. If you see anything outside, just know that those particular values, they are outliers, right? Outliers are something that are not supposed to be where they are. They don't conform to the distribution that you have currently. So they usually pose as a problem sometimes. So you have to deal with them. So Boxplot actually reveals outliers and it is very good at it. So whenever you see a box like this, everything should fall in between this range, right? So this box contains the 50% of our data. So the 50% of our data actually should be contained within this box. So there's a middle line here. The line that is here corresponds to the median or the mean, sorry, the mean of our data. All right, so this is where our mean is. So the mean should ideally be at the center here. So you always see a line in our box plot. So this line corresponds to the mean, right? The middle number. Okay, so basically, that is how we represent the box plot. So we have Q1, we have Q3. So there's what we call there's what we call quartiles in statistics. So quartiles are just sections of our data. We have the 25% quartile, we have the 50% quartile, and we have the 75% quartile to the 100%. So from year to year is 25, 0 to 25. Then we have 25 to 50. Then we have 50 to 75, and then we have 75 to 100. All right. So that the different quartiles we have in our box plot. So all these things are just statistical terminologies, right? So it is mostly used when you want to actually get all this information, all right? And whenever you want to perform outlier, so when you are asked to check if there's an outlier in your data, just use box plot because box plot is the best. Once you use it, you are going to be able to detect outlier. We're going to demonstrate it, right? Hopefully, if we have enough time during the class. So that is it for box plots. All right, so let's move ahead to what we have. So we've looked at the different visualization techniques. All right, we've looked at line chart, we've looked at bar chart, we've looked at scatter plot, we've looked at pie chart, we've looked at histograms, we've looked at heat maps. So heat maps is usually used for correlation, right? So and a lot of other things. So between two variables. And we've also looked at box plot. All right. So let me see if I can get this to be on this other place here. Oh, All right, so I'm going to update the material with this, so you can see it as well. You can have it in your material because I already uploaded this material to the Google Classroom. All right, so let's just continue. Now we are going to go into Matplotlib now and look at Matplotlib, right? So we're going to explain what Matplotlib and look at the core concept in Matplotlib. All right. So now in Matplotlib, we have several things you have to know. All right. First, we have what we call the figure. So these are concepts that you need to know, but as we start plotting, it's going to make a lot more sense to you. So, but there's something you need to know. That's things you need to know. Number one is figure. So the figure is the main thing, right? It's like the canvas. If you're an artist and you want to paint a picture of somebody, what do you do first? You bring a canvas. A canvas is like the platform on which everything you'll be drawing would be on. So that is the same thing here. So a figure, as we have it here, is the top level container that holds all the elements of your visualization. So without your figure, you cannot have any visual. It's impossible to have any visual. All right. So imagine it as the canvas on which you paint your plot. So exactly what I just explained now. So you can basically create figures in Matplotlib. Whenever you create a plot, it automatically creates a figure for you. So you don't have to necessarily create figures manually, but you can as well create figure manually. And I'm going to show you how to do that. But when you create a plot, you Matplotlib automatically create a figure and then plot on top of that figure, right? So a single Matplotlib session can have multiple figures. Yes, you can have as many figures as possible. When you plot histogram, that is one figure. When you now come and plot bar chart in that same notebook, that's another figure. When you plot scatter plot, you are plotting on another figure. So you can have several figures in a particular Matplotlib sessions, all right? So that is what figure basically is. So we have our axis. So this axis is something you know already. Axis is basically the coordinate system that defines the x and y for your plot. All right. So all these things are actually handled by Matplotlib itself. You don't need to manually set them. So once you plot or make your plot, all these things are there already, right? But you just need to know what is happening. So each plot within a figure, right? So I'm going to talk about what a plot is, but each plot within a figure has its own axis, all right? So determining scaling and labeling of your data. So the axis is the x and y. So depending on the variable you want to plot on the x-axis, is going to create a scale for that variable, and it's going to create a scale for the variable on the other axis and plot it for you. So all these things are done at the back end, right? You don't need to stress yourself about how all these things is being done, right? They are being done for you by Matplotlib itself. So that is what we have. We have talked about figure, we've talked about axis. Now, plot. Plot is like the particular visual that you want to represent, or that you want to represent, right? So, or that you represent with the data. So a histogram now is a plot. A bar chart is a plot, all right? A scatter plot is a plot. A line chart is a plot. So all these things, they are plotted on top of a figure. These are data representations, all right? They are being plotted. So it's not the same thing when you, as an artist, you have your canvas, which is your figure, and then you now set your axis, your y and the x axis. Okay, so okay, this is the length of the x axis I'll be using, and the y axis, and you now start on top of your canvas and your axis. You now start drawing somebody's face. That person's face you are drawing corresponds to the plot exactly. So that plot in Matplotlib corresponds to the person, the thing that you are actually drawing on top of your canvas. All right. So in the case of data visualization, the plot is your graph or your chart. You can see, as you can see here, a specific data plot is a specific data representation within a figure. This could be a line chart, bar chart, scatter plot, or any other visualization supported by Matplotlib. All right. You can have multiple plots within a single figure. Yes, you can actually have multiple plots within a single figure, but that is actually more advanced data visualization. But what we're going to be doing is basically just focusing on how to plot one plot on a single figure. So having multiple plots on a single figure is what we call subplots. So subplot is when you want to create multiple plots on a single figure. It's like, imagine now that particular artist now divided the canvas into four parts, into four equal parts. So on the top left, they drew is a different image, maybe an image of somebody's face. And on the top right, they drew another image, maybe a leg. All right. On the bottom left, they drew another thing, maybe the hand. And on the bottom right, they drew another image again. So you can see that they've used one single figure for four different plots. So that is what we call subplot in Matplotlib. So you can actually have a figure you can actually make a figure to have four different plots, all right, in one particular plot, in one particular figure, rather. All right, so that is what we call subplot, and there are ways we can do that. We might not do that today. Maybe when we start machine learning, we might just look at it, but just understand that we can have subplot in Matplotlib. All right. So let's go ahead to the next thing, which is artist object. All right. Artist object is basically every other thing that you see in your plot, every other thing aside the plot itself. So when you've plotted your bar chart, that is your plot. But when you start having things like titles, legends, text labels, markers, every other extra thing on your plot, on your figure is the artist object. So that is basically just it. So you can actually control what you want to appear. You can control the title of your plot. You can control the legend. You can control the X label. You can control the Y label. So Matplotlib gives you this power to do all these things. All right. So as we are going to be moving forward, you see how we can actually do all these things using Matplotlib. All right. So as you can see here, these objects have properties that you can customize to control appearance and behavior. So you see in a short while that we can control the appearance and behavior of our charts. You can change the style of your chart as well, right? I'm going to demonstrate that. You're going to see it. You can change a lot of things. You can tweak it. You can change the color. You can change the width. You can change a lot of things. All right. So Matplotlib gives us that power, right? And we are going to look at that shortly. All right. So that is it for the different Matplotlib concepts. So I've gone over figure, right? You should understand what a figure is. Then I've looked at axis. We've looked at plots, we've looked at subplots, we've looked at artist objects. These are just simple concepts in Matplotlib that you need to understand to proceed with using Matplotlib. All right. So these are just additional concepts, right? These are just things that you'd also be seeing as well. Legends, you know what legend is, color maps, annotations, so all these things are just to customize your charts even further. All right, so now we've finished the part 1 of this lecture. We're going to go into part 2. So part 2 is going to be about implementing or using Matplotlib to plot. Right. So we've looked at how Matplotlib works, what visualization is, benefits of visualization. Now, how can we use Matplotlib in our notebook or in Python, right? So let's just go into our explanation sheet. So what do we have here? I'm going to cut this. Okay, first thing first. What do you do first? You import it. All right. So you import your library because it is not built into Python. So you have to import it. So how do you import Matplotlib? Matplotlib, you don't just import it, import matplotlib as maybe maths. No, this is not how you do it. Matplotlib has a module that you that we will be using for plotting, right? The functionalities that we need to plot are not directly in Matplotlib. It is in a module inside Matplotlib. So what we have to do is to say we can import it using two ways, in two methods. So first method is by saying import matplotlib.py plots. Now you can see that I think we've done this thing before, right? When I said import numpy dot random, right? So okay, I don't know if we've done this before, but basically I've explained that NumPy has a sub module which is called random, which has functionalities that we can use to generate random numbers. So the same thing applies here in Matplotlib. Matplotlib has a module which is called pyplot. So this pyplot is what we're going to be using in plotting. So to do that, we're going to say import matplotlib.pyplot, and we can come here and say as plot PLT. So this is the standard way of importing Matplotlib. So this is the first method, right? So the second method is by just saying from Matplotlib import by plot as what? Plot. All right, so this is the second method from Matplotlib, right? So you're telling Python that, okay, from this particular library, import pyplot as plot. So these are the two ways that we can import Matplotlib in Python. All right, so this is the first thing you do when you want to use Matplotlib. You import it using either of this method. I don't have any problem. Use any one, it's fine, but just make sure that you import it accurately. So we'll run this. All right, this should run, and then we'll come here, and we are going to, because we will be working with data. All right, we want to visualize our data, so we are going to also import pandas as well. So I'll come and say import pandas as what? PD. So I'll come here and import our data set and say df equal to pd.read CSV. So I think it is retail transaction.cs. So this CSV file is available for us in case you want to follow along. It's available on the Google Classroom. So I'm going to run this. I have my data, right? If I come and say df.head, you can all see my data, all right? So what I do normally, I'm going to quickly rename it because we are going to be working with the different columns. So I'm going to come and say df is equals to df.rename, and I'll say columns equal to, so I have customer ID, so I have customer ID, and then I have ID. All right, come here, and I think I have product ID. Come and say product. I'll just say product. All right, come and say transaction date. Transaction date. Come and just say date. All right, I think payment method as well. Payment method. I'll just come and say method. All right, come to the next one and product category and say category. I'm doing this so it's easy for me to reference the columns when I'm like calling them. So the next one, I think discount applied. All right, I think it comes with a bracket and a percentage sign. So I'll just leave it at what discount. All right. So that is it for this thing. I'm going to rename it. So if I come here and say df.head, right, I should have everything renamed. All right. So yeah, let's see. We're going to convert everything to small letter. I'll come and say columns is equals to df.columns. Okay, I want us to give me the code for converting my columns to small letter. Like quickly in the live class, let's someone can I get the code for converting my my column names to small case or lower case? All right. All right, that's okay. So I'll just come and say columns dot string dot lower. All right, so this is going to do justice to it. So if I come and say df dot head again, you can see I've converted everything. So now let's quickly start implementing the different visualization technique that we've learned. All right. So first of all, I told us that we're going to look at how to handle dates in Panda. So I want us to pay attention here. So in this case, we have a date variable here. So this particular variable, if we check the data types of our variable, come here and say df.datetypes, you see that the date variable is an object. So pandas is not recognizing it as a date, right? So what we have to do is to convert it to a date. So pandas will recognize it as a date and will be able to work with that variable as date. All right. So how do we convert it? So to convert it, we basically use a function converting our date variable. So we use the function we're going to call the column, right? So the column is what? Date. So we use the function we're going to use the function pd.datetime. All right. So pd.datetime is our function. If you use what we'll put here is the variable, right? So the variable that we are going to convert is the date variable. We're going to put date variable here and run it. So it should give us what's it? Hope I'm getting the correct spelling of the date time. Let me DAT. I want to be sure. Okay. I think it's to date time, not date time. So I think there's two here. Yeah. So basically, this is it. So the function we use is to date time. So if you use our shift and tab, you're going to see what it does. So it converts an argument to date time. All right. So in this case, it's converting our variable to date time. So how do I do it? I'm not going to reassign it. I'll come here and say df date and assign the output to our date. So I'm going to run it. If I come here and say df.head again, you see that it has given us it has actually converted it to date, right? So how do we know? If I come and say df.date types, you see that the date time variable is now in a different data type format. You can say date time and these other things we have here. So you can now actually work with it. So that you can perform different date time operations, right? So there are actually different date time operations that we can perform. You can extract the month, you can extract the day, you can extract a lot of things, right, from our you can extract a lot of things from this particular date time variable that we've converted. So let's just look at how, so because this is what we're going to be using for our visualization. So let's start with date. Let's extract the months from this date time. So before we do that, let's see the variable. So the variable here is what? Date. All right. So this is our variable. So this is what we're going to be working with. So if I come here and say .dt, the same way we came here to convert our columns to string by saying .string. So this dot string gives this the columns items access to all the string functionality. So the same thing applies here. So if I say .dt, I can now apply a lot of things, right? I can apply a lot of functions. So if, for example, if I come and say .month name and I run it, you can see that it extracted all the month names from this date that we have here that we've converted. All right, it looked at the dates and it extracted the months and the names of all. So we can actually pass this output into a new variable. So I can come here and say df and say month, all right, and say equal to date, and it will pass it to my date. I can do the same thing for days. I can say df date, all right, .dt days. I think if I'm correct, it should be days, right? So let me see. Okay. The name. All right, so basically this is the function to extract the day name of our dates, right? So all this corresponds to the particular day from the dates that we have for each observation. We can also pass that to a new variable and say df days and do the same thing. All right, so this is it basically, right? This is how we can extract, this is how we can work with date time data. First of all, what you do when you have a date time variable in your data set, you convert it to a date time data by using pd.toDateTime function and passing the variable of your data frame. It will return the accurate format of the date that you have here, which will now be recognized as an appropriate date variable, and that date variable can now access several functionalities, right? Several functionalities. So if you want to see other things that you can do, you can come and say df date and just say .dt, all right? So if I come here, I think it should be the dir, if I'm not mistaken. The date, it should have dates here. So you can see if we scroll down, these are the different functions that you can access. So you can see all these things. You can see day of the year, you can see day of the week, you can see day of the year, you can see a lot of things here. You can see days in month, you can see day, you can see date, you can see a lot of things basically. You can even see second, you can see time. So you can try it yourself, all right? You can try, you can even convert time zone, you can even convert weekend and year and all of that, weekday. So see, there are a lot of things you can do, all right? So Pandas is very, very interesting. You can work with day very, very efficiently, dates rather, very, very efficiently in Pandas, all right? So this is just the tip of the iceberg. So all we want to do here is just to extract the months and the weeks sorry, the weekdays, so we can visualize, use it in data visualization. So let's just move ahead. So now we've been able to, let's see our data frame again. We've actually, so you can see we've added new variables. We've added month variable and we've added days. So you can see, let's just look at it now. This is the date, right? 2024, January 31st. So if you come to month now, you see that the month is what? January. And this particular day, 31st, if you check it, is actually on a Wednesday. Do you understand? The same thing here, 2023, 06 is what? June. You can see June here. And if you check this, you see that this part is actually on a Monday. All right, it's actually on a Monday. So the same thing goes for all the other ones that we have here. All right, so that is basically the how you can extract this information from date time in pandas. All right, so hope everyone can still hear me clearly. Please confirm if you can still hear me clearly. So I'll move ahead. All right, beautiful. So we can actually do a lot of other things, but let's just work with this. So now let's start with line charts. All right. Um, Line charts. So now, so I want to extract, I want to get, I just want to get the frequency. I want to perform univariate analysis on months here, just on months and days as well. So I'm going to do so let's just start with month. So how do I do? I'm going to get the month. So I could come here and say months. And to give me this. So if I want to get the frequency of each of the month category in this particular variable, how do I do that? I want to get the count frequency of all the months in my data. I want to get the number of time January appears, number of time June appears, number of time, what code am I going to use? We did this yesterday, so quickly, let someone tell us in the group chat. I believe we still remember we did that yesterday, so I'm waiting for us to give us an answer to that. All right, our class rep said value count. Okay, I need the because I'm going to copy exactly what you wrote and we're going to try it. So make sure that you get the spelling and everything accurately. So without wasting time, let's just see it. So dot value count. All right. So let's see. Wow. So you can see that it's giving us an error. So that means it's not correct. So what is the issue here? Can someone give me the okay? That Tijani said value count with an S. DF month value count with an S. Beautiful. So you can see that this is the correct one. So I need you to pay attention to all these small details. There's an S in front or after the T. So it's not just value count, it is value count with an S. All right. Anything otherwise is going to give you a different thing. So these are the values, all right, of this thing. So we want to represent this now in a line chart. All right. We want to represent it in a line chart. So how do we do that? I'm going to just assign this to a variable. I will say month, right? And then come here and say the month is what? If I say type, let me see the type of the data. Is a panda series, all right? So to extract the values, how do I extract the values? So our x-axis, I can say x-axis is equals to what? So how do I extract the values of my month, my series data? How do I extract the values? What code will I use to extract just the values? All right, we are very, very sharp in this class. Like, and I like it. Like, we don't forget things at all. So that is nice. So please, I need more answers, more answers, more answers. Someone said dot values. What dot values? I just put dot values like that. Someone said month dot values. Abdullah Shamsuddin. Okay, Douglas said PD dot values. Someone said month dot space capital letter v values. So whenever we're writing code, please let's just get the syntax correct. All right, we should pay attention to the capital letter and the small letter, the spacing and all of that. So just try to get it correct. So basically what we're going to do is just say month dot what values, right? For our y-axis, sorry, this should be our y-axis rather. For our x-axis will correspond to what? Our in sorry, before I say that, I need just to quickly tell me. So what is going to be on our x-axis? What is going to be on our x-axis? Anyone? Exactly. Thank you, Muhammad. Index. So it's going to be month dot what? Index. All right. So if you run that, okay, month with an S, with an S. So if we run that, we would have gotten our x-axis and our y-axis. So how do we plot our line chart? Plotting our line chart. Okay, so basically we are going to see how we can plot our line chart. But before we do that, you just give me a minute to this thing. All right, so basically, how to plot our line chart? We'll just use the function plot dot what. You know, we imported plot here, PLT, right? So this PLT has a lot of functions, right? One of them is plot dot plot, which is used for line chart. So if you put a shift, let's see. If I put a shift tab, you're going to see that it will plot y versus x as lines or markers. All right. So what we have here, we're going to have our I think our x axis first. X. So I think I should move this axis and just make it x and y. So I'm going to have our x here and I'm going to have our y here. So if I plot that, you're going to see this particular, let me zoom out. You're going to see this particular line chart. So you can see it here. All right. You can see that there is a decline, or although this is not arranged according to the order of the month, right? From January to December. There's a way we can do that. But basically, this is just showing you how we can plot our line chart, the line chart of a particular time data. So you can see that this line is moving down, which is showing that this particular value here is the one with the highest, right? Going down, going down, going down till we have the last year, which is July. So this is basically what we are going to get when we plot. This is our figure. Everything here is our figure. All right. This is our y-axis here, and this is our x-axis. So this is the very basic plot. So we can actually customize this, and I'm going to show you how we can customize it. So first of all, you can see that this thing is jam-packed. All these values here, they are jam-packed. So we need to align them in a way that we can see them individually. All right. So to do that, we can basically just come here and use a function called plot.sticks. So sticks is a particular function that is used to rotate. You can use it to rotate your label. All right. You can actually use it to rotate your label. I think the value is rotation equals to 45. All right, if I'm correct. So you can see that we rotated it here. Everything is now rotated. So you can see the months separately, not jam packed. So I can actually rotate it to be 90. 90. So it will just be like straight. So straight, right, corresponding to each line. So this is basically the basic way to plot a graph, a line chart. So we can now start customizing. So this is what we're going to do now. We're going to customize this chart, and I'm going to show you how to do that. First of all, whenever you plot a chart in Matplotlib, make sure you use this function plot.show after you've plotted. What this plot.show does is it just displays only the graph. It removes all this text that will appear here, right? It will remove all this text. So if I run this, you see that it has removed all the text. It just displayed the graph for me. So to avoid all those text that you'll be seeing, just make sure that you indicate or you include this plot.show function after you've plotted. All right. Now there's something that you need to do at the beginning of importing your modules. There's something you need to import from Matplotlib, which is what? Style. All right, which is what? Style. So we can import style from Matplotlib. So we can say from Matplotlib import style. So this style is used to decide the theme of your visual or of your visualization. So any plot you are going to be plotting throughout your notebook will conform to the style that you set it at the beginning of your notebook. So once I import it, you can just come here and set your style. So I'll just create a new this thing and say setting style. So this style has several functions. It has one function called style dot what? Available. So if you want to know the available styles, you can come here and say styles dot available. Okay. Let's just use plot dot style. Plot from Matplotlib. I think you have to import. You should have style. Matplotlib should have style. So I don't know why it is telling me that style dot available. Okay, it's working now. So style dot available will show you the different styles. So you can see that it returns a list of different styles here. You can see a lot of them here. So you can try out different styles. So we're going to try out this one, ggplot. This one I like it. So we're going to try this one. So to use a particular style, what we do is come here and say style dot use, and in the bracket as an argument we're going to put that particular style, which is ggplot. So if I run this, it's going to set this style. So any plot I'm going to be plotting from now is going to conform to that style. So let's try it on this plot that I've plotted. You can see that this plot does not have any style. Can you see? It's just white. So if I come here and rerun it, you can see now that it has a style. All right, the ggplot style has been applied to it. Can we see how like flexible Matplotlib is? Can we see how interesting and how we can customize our visualization? So this is we're just even starting with the customization. So let's just try another one. Let's try another style. So let's say the available style. So we can see this one. Let's try seaborn.dark. Seaborn dark. So I can come here and change the ggplot to dark. All right, and run it. Right, I'll come here and change my style and run it again. You can see that it's giving me a different style. So it basically changed the font and just remove the grid for me. So there are a lot. You can just be trying any one, right? You can just try a lot of them. But what I like using ggplot. So I'm going to just rerun this. and you're going to see we have this. All right, so that is how we can customize the theme of our visualization. So now we're going to show you how we can manually set our figure. I told you that whenever we make a plot, Matplotlib automatically create a figure for us with a particular size. All right, so this figure has a size of X, and a size on the X axis and a size on the Y axis, but we can set it manually. So the way to set our figure manually is to come and say plot dot figure. All right. So this plot dot figure is a function, and the function takes as keyword argument fig size. All right, fig size. Let me zoom in so you can see it. It takes as argument fig size. So this fig size is equal to, it takes a tuple of two numbers, X and Y. So the first number corresponds to the X axis and the second number corresponds to the Y axis. So in this case, you can say I want my X axis to be 10, the length of 10, and I want my Y axis to be like 6. All right. So if I say okay, and I run it, automatically, you don't need to do any other thing. This figure size will be applied to any figure that you're going to be plotting in this particular place. So if I run it, you'll see that the figure, what exactly is it? Okay, fig size S is supposed to be here. All right. So you can see that my figure has increased. The size has actually enlarged because I have defined the size. I've changed the size from the default size to making it 10. So 10 is going to make the x-axis to be longer, while 6 is correspond to the length of the height of the y-axis. So if I make it 5 here, you're going to see that it will reduce in height. You can see that the height has reduced, right? The height has reduced, and then the length, which is the x-axis, remains the same. So this is how we can customize our figure, by customizing and changing the size. All right. So we can do a lot of other things. All right. We can give title to our figure. I come here and say plot.title and say line chart of month, or I can say it should give you a descriptive, this is month frequency. All right. I can also give my x axis a title or a label by using x label. Let me zoom in. X label, and saying this is my what can I call it? Okay, this is month, but you don't actually need to do that because everybody know that is the month, right? So, but I just want to show you, you can give your y label to y label and say this is your count or frequency, right? Count. So these are the things you can do to customize. So if I run this, you see that a lot of things have changed. Like my visualization has gotten a title. You can see a month frequency. You can see that the y-axis has gotten a title as well, count, a label, and the x-axis has gotten another label, month. So this is very, very interesting. There's a lot of customization that can be done. If you look at this plot function here and you do shift and tab, you'll see that there are a lot of things you can actually do. All right. Right. Although there are a lot of things you can do here, but I think we are not going to explore all of them. But let me just show you a few. One of them is color. You can change the color of your line, right? I can change it to orange, let's say yellow. All right. If I run this, you can see that it has changed to yellow. The line has changed to yellow. If I come here and say green, you can see that it has changed to green. All right, so you can just be creative with your customization. You can say pink, any color you can think of, basically, it is going to do it for you. All right, if I come and say orange, right, it gives me this. So you can customize a lot of things. All right. to see the different parameters or the different parameters in your plot, I think it's better you go to the um, documentation online, the online documentation, to see all the things that you can customize. All right, to see everything that you can change and tweak to make your visualization look better. All right, so let's just see some of them. So it's difficult to maintain this one because I'm trying to show this visualization at a glance. All right, so I'm definitely going to be increasing the font. So let's see plot dot plot para parameters all right, so we're going to see all of this. Hope everyone is still following and hope you are enjoying this class. So you can see this is the documentation, right? This is the documentation of this plot, all right? So everything that you need to know about it is here. So these are the other functions, right? In PyPlot module, everything is here. Everything you need to know is there, right? So let's see if we can get the other parameters. Let's see if we can get them here. So basically, so yeah, so you see them here. So you see we have markers basically, right? We have markers here that we can use. Let's see. We have line style as well, all right? So let's quickly see colors. We have colors, all right? We have color. We have character. This character is for, so let's just explore, but let me just take one example from here and see if I can just use it. All right, so I'm going to look at line style now, line style and marker. So let's just look at line style. Let's look at line style. So we have different line style here. We can have dash, right? We can have asterisks. We can have equal to. So let's look at asterisks first. So we'll use that. So if we run this, am I getting it correctly? Okay. Okay, so the different line styles that we have here, all right? So dash, double dash, and this. So let's look at those things. So sometimes you just have to look at the different documentation so you don't. So you can see that the line style have changed now. Let me make it a better color so you see it very well. Green. So you can see the line style, it has changed to dash, 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 right? So because we indicated it here, all right? So we also have what we call line width. So this line width is, I think, yeah, is a float, is a number. So if I say 2, it's going to correspond to, it's going to make it thicker. If I come and say 5, it's going to make it thicker, as you can see here. So it controls the width of your line. So I can say 0.9. All right, you can see it makes it very, very tiny. So there are a lot of things you can customize. Let's see other one. I think we have marker. I think it's marker. Okay, yeah, marker. So it's the marker that we can use as asterisks that I mentioned before. So this asterisk is basically going to give you the point where the X and Y axis intersect. So you can see this. You can see where they intersect. It just gives you a kind of intersection, and you see. So The thing you can do is just limitless, basically, right? Is limitless, all right? You can actually even style your fonts to select a particular font. So let's see if we have that here. Okay, there's one we have alpha. Alpha is basically used to control the transparency. So if I come here and say alpha is between 0 and 1. So if I say 0, it's going to be completely transparent. You will not see anything. If I say 1 is going to be completely opaque. It's going to be normal. But if I say anything between 0 and 1, let's say 0.5, it's going to be a little bit transparent, right? You can see it here. It's not rich, it's not opaque completely, but it's transparent. So you can just select whatever, you can just play around with all these things. Like there are a lot of options here. You can see all of them here. If you go to the website here, you see every single thing here. So these are the properties, right, that you can apply. You can actually apply all these things. So we can't look at everything because of time. All right, we can't really look at everything because of time, but there are a lot of things that we have here, a lot of them. All right. So yeah, that is it for visualization. Line chart. So I've already gone over how to customize our V's. So what I'm going to do now is just show you how we can plot other visualization, and then we call it a day. All right. So now let's look at bar charts. All right. Let's look at bar chart. All right. So for bar chart, which particular data we're going to use now. Let's see. I think we're going to use the category. All right, let's use category. I want to plot the frequency of our category. So I'm going to come here and say df, or let's say categories, and it's df the category, and say value count. All right, I'll come and say x is equals to category dot values, and sorry, y is equals to category dot value, and what x is equals to what? Categories dot what? Index. So bar is what? Plot dot bar, bar. All right, what you have here, you have your x and y, and then you come and say plot dot show. All right, as you should do, always do. I can control the size and say plot dot figure, and say fixed size equal to what? Let's say 9, or let's say 7 by 5. All right, 7 by 5, and just close it. Okay, so we have this. We can also come here and say plot dot title, and I can say categories. All right, I can say plot dot x label, and I'll say my category, and say plot dot y label, and say count. So these are the basic things you'll be doing. So if I run this, I'm going to get this. All right, so you can see my categories. You can see them. I have electronics, I have books, I have home decor, I have clothing. So this bar chart will automatically show you the one that is more. The electronics obviously is the one with the highest value. Clothing is the one with the least. So you can style it basically. You can actually change the width of your bar. I think let me see if I can get the the width. So the width, we can change it. Let me come here and say width. I can say, let's say 6. All right, 6 is too much. Let's say 1. Is that the correct? Let me see if as the correct. Okay. Okay. Line width. Okay, not just width. So that's why you need to always check out the. So I'm going to go here and say 2. So you can see we can control it. Let's say 1. Um, Let me be sure that I'm using the correct. So this is just exploration, basically, right? You can do a lot of things here, but it's not it's not compulsory you do that. But let's see. So just not to waste time, not just waste time. Let's see 0.1. All right, okay, great. It's actually width, but I was not getting the value. So I think the width is between 1 and 0 and 0 point, let's see 0.7. All right, let's see 0.5. Okay, you can see now that you're controlling the width actually. So 0 point, I think the highest here, let's see 0.9. Okay, so great. Okay, I think the highest is 0.8. Okay, 0.8. All right, this is the highest width here. So you can just go below 0.8 and to just customize it. So you can have 0.3 to have tiny this thing. So if you have a lot of categories, you can decrease the width actually to make room for basically for all the categories. So these are the things you can do to customize your data. All right. So that is how to plot your bar. If you want to make it a vertical bar, you just put H here. You put H here. Let me remove this. So you're going to put. Let me zoom in here. So to plot your vertical bar, you are going to put H in this bar. If you remove the H to plot vertical bar, but if you put the H, you plot horizontal bar. So this is the horizontal bar here. As you can see, it has been plotted for you. All right. So you just have to change this X axis and the Y axis. Just change it Y label and what X label. So it is going to change to category and count. So this is bar chart for you. Very simple and straightforward. All right. So let's quickly, because of time, we need to be rounding up now. Let's look at scatter plot. Scatter plot. So let's look at scatter plot. So scatter plot is for numerical value, as I told you. So let's which of our variables are numerical. So we have discount. We want to compare price and what discount. So scatter plot is straightforward, right? Very straightforward. So our x in this case, we can make anyone x, can make price s. So I'll come here and say df dot price and make our y df dot discount discount. All right, so I can come here and say plot dot scatter. I think it should be scatter. I think is Matplotlib that is scatter. All right, scatter. So scatter will have x and what y. So if I plot that, I'm going to get something like this. So now scatter plot also shows you outliers. All right, you can see now that we have a problem with this particular data set. So let me even just plot just our x. Okay, let me plot x and y. It shows you outlier basically. You can see that we have an outlier here. This particular the x label. Let me plot dot x label should be price. Plot dot y label should be what? discount plot.show. So you can see that our price here has high values at this point and at this point. So these are outliers. You can also use scatter plot to detect outliers, the same way we can use box plot. All right. So now, before I remove this outline, let's quickly look at box plot. So we're going to say plot.box plot. I think that should be the name. All right. So your box plot, we're going to put X there, and we're going to do this. So what do we have here? So this it should be giving us. Anyways, let's quickly remove this outlier first. So now we can see we have this outlier at 75 and 17,500 for price. So this can pose as a problem because it's actually out of the range of our price here. So it might be that our customers actually bought something for that price. It might also be that they made a mistake while inputting the data, so they put the outrageous amount. So as a business person, you will know the things that are possible and the things that are not possible, right? So to remove that, we can just come here and say df price, and we can say n largest. N largest is going to give us the n largest values in that particular column. So this is a new function, all right? Let me zoom in. This is a new function. So you can see the two values here that are outliers, the 7,000 and the 7,000. So it has index what? 78 and what? Index 64. So we can easily just remove it. So I'll come here and say df and say drop and say index 78. I'm going to put that in a list, 78 and 64, and specify the axis to be 0. All right. Let's see if it will work first. So you can see that it actually worked because we returned this. So we're going to make it permanent. I'm going to come here and say df equals to this. All right. I'll come back here and do the same thing again. So you can see that the scatter plot now is now making sense. All right, because we've removed those outliers. So we even still have some outliers here, 1, 2, 3. There might be outliers, there might not be outliers, but let's still remove them. So I'm going to remove them. So in this n largest, we have what? We have 321, 221, and 190. So index what? Let's copy this. Index 359. Index, let me zoom in. Index 17 and index 467. All right, I'll comment this one out and run this and come back here and run the scatter plot. You can see now that our scatter plot is now giving us a nice output because we've removed the outlier. So the range of the data now makes sense. Now, this, you can see that this particular scatter plot doesn't really have a direction. So basically the correlation is almost 0 because the scatter plot is not moving in any specific direction, right? So I think yesterday we saw that the correlation between discount and price is slightly positive. That is 0.04, which is almost 0, right? So this is the visual representation of what we saw yesterday. So this is what we expect, right? When we plot our visualizations, we understand our data better. We use it in data exploration, and we use it to basically get insights from our data. So let's quickly look at another visualization. So you can actually compare price and quantity as well, and price and quantity and discount to just on your own in your own free time. You can compare it to just see the differences. All right. So let's see for histogram. So we can. So I'm going to show you how we work with histogram. Histogram. All right. Okay, this is supposed to be marked down. Right. So histogram is for numerical data, right? So we come and say plot.hist, right? Hist, I think it should be hist. All right, great. That is hist. So we'll look for one particular numerical data. In this case, let's use price, right? Let's use price. Then you're going to see the histogram here. You can see the histogram, right? This is what the histogram looks like. It doesn't have that line that we saw, but it's not a problem. We can actually include that line by customizing the plot, all right? So if you do shift tab on the histogram, you can see a lot of parameters here. You can see a lot of things that we can put here. So the bins, you can see, I told you can actually specify the bins. The bins are those bars that actually represent a value, right? We have stuff here. So let me see if we can get the okay. All right. So let's quickly change the bin. So if I come and say bins is equals to, let's say, 50, you see that it will become smaller, right? Because each of these now will correspond to 50, right? You are making the bins more. If I say the bins is equals to 100, it's going to be even tinier, all right? So this is the distribution of the price in our data set. If I say the bin is equal to 10, we're just going to have 10 bins. So this is how we can actually control the bins in our histogram. So this is the histogram plot. As I said, is used for numerical data set and numerical variable. So hope everyone is still following. We are rounding up now. We are almost done. Hope everyone is still following. Please give me a let me know in the group chat. All right. All right. All right. All right. That is great. So let's just go ahead. We'll be done very soon. So now, as I said, like this is supposed to have line, all right, as I showed us initially, but we can customize it by default. The line will not be there. So there is, if you look at the different this thing here, I think there should be a parameter called edge color. I don't know why we can't see it here, but there's a parameter called edge color. But okay, let's just try it if it will work. So I'll come here and say edge. So this Matplotlib is all about just trying out different things. All right, edge color. Let me say black. So this is, I think this is it. So the edge color by default is the same color as our bins. All right. So if I change my bin size to, let's say, 35, you can see I'm going to have this, right? Let me change it to white. All right, so this is what we're going to be having here. I can change my color. Change my color to, let's say, green. So we're going to have this. All right, so this is basically our histogram. If we change the data here to, let's say, discount, this is what we're going to do. So this is the distribution. It is not normal, right? Normal distribution has to be a bell curve shape. It has to be perfectly bell curved. Like a bell curve is something that has a tail. Let me see if I can get it here. Bell curved histogram. All right, so this is it here. So all these things you're seeing, that bell curved, all right. You you expect your data to be this shape you are seeing now on the screen. So this is what a bell curved histogram is. So this is how it should be for you to consider it to be normal, right? So if your data is not like this, then there is a problem with it. You need to perform some manipulation to bring it to become bell curve. So the ones we saw here, this particular one is not bell curve. It is not normally distributed, right? You can see it doesn't even have a pattern, right? The price variable too is somehow bell curved, is also almost normal, but it's still not perfect as well. So these are the things you look out for. This histogram is basically used to look out for this bell curve shaped right now data set. That is its function. That is all it does. All right. So can you access numerical variable and check out the distribution of your data set. All right. So that is it. Let's see what we have not looked at yet. We've looked at histogram. Okay, we've not looked at pie chart yet. So pie chart is basically straightforward. So pie chart. All right. So I think pie is it here. So pie chart just takes, let's say we have our categories here. Let me just copy because of time. Is for categorical data, as I've said. All right. So let me get our categories here. And I'm going to come here and just put it. So it takes your X, and I think it takes labels. Labels is equals to Y. Sorry. This one is Y. Label is equals to X, if I'm correct. All right. So this is it. This is our pie chart. All right. You just it creates a pie sections for you and correspond it to the different categories. So you can see all this text. So I'm going to put plot dot show to remove it so you can see it there. So we can actually include the numbers here. There are different ways to do that. If you check out this thing, so this is the function here, auto percentage, right? If I come and say auto pack is a formatting method, a string formatting method that we use in including the percentage in pie charts in Matplotlib. So I don't know if we should still go straight into that because of time, but let's see. Okay, it's a string formatting method, right? Let's see. You just have to remember it. It's something that you can easily forget. But let me see if this one is correct. It should have F and percentage and this. So exactly. So this is what you should always have in your auto percent function. You just have this particular, you can just write this out somewhere or just learn it. This is the standard, right? So it takes in this value here and convert it to percentage and then apply it here to your pie chart. So this is just, it's straightforward. Plotting in Matplotlib is actually very, very easy. All right, very, very easy and straightforward. So I think that is it for the charts that we have so far. Um, we've been able to cover a lot. We've been able to cover a lot actually. We'll still be referencing some of these things as we're moving forward. So this is the foundation for visualization in Python. All right, this is the foundation for visualization in Python. So let's just make sure that we understand all these things that have been discussed today. Please, you go over this video, make sure you understand it. There are several things I've explained here, several visualizations, line chart, bar chart, scatter plot, histogram, pie chart, Heatmap. I told you that Heatmap, we're going to look at it when we start machine learning. For box plot is also the same thing, but let's see here. Let's come here. I think, don't know why this is giving us an issue for taking in the data. It shouldn't. Anyway, let me quickly do something here. So I have introduced us to Matplotlib, but there's another library called Seaborn. Right, Seaborn is a library that is built on Matplotlib. It's also used for visualization as well, right? So it's something you can use. You can either use Matplotlib. So they integrate very well, right? They integrate perfectly, all right? So let me come here and say SNS. Okay, so SNS does it very, very well for me. So this is basically what you're going to get when you do your box plot. So this is the distribution. And you can see Seaborn actually does a lot of things for you. You don't need to customize. It automatically label, it automatically format for you. You don't even need to use plot.style because it styles your visualization. The reason why we start with Matplotlib is because Matplotlib, you have to do a lot of customization yourself, so it helps you understand how to upload visualization in Python. All right, but Seaborn does all those things for you. It takes care of a lot of all these things. All right, so but we are not going to look at Seaborn. We're going to Seaborn as we are moving forward. So, but Matplotlib is what you need to know as a data scientist, right? Everything is built on Matplotlib. Seaborn is built on Matplotlib. The same way NumPy is like the foundation of other libraries, Matplotlib is the foundation of other libraries for visualization. Any visualization tool in Pandas, in Python, is built on Matplotlib, right? The integration is very seamless. So the reason why I imported Seaborn was because I wanted to try out the box plot, but I don't know why Matplotlib is having issues with that. So that's basically it. This is just a starting point. You can go and explore. You have the data set, you have this video, just try it yourself, all right? The customization, I didn't even go, didn't even touch the limit. So there are a lot of things you can actually do. Please try it yourself and you see that this is something that is quite interesting. Matplotlib is flexible and a very interesting library. All right, so we've come to the end of today's class. Right, we've come to the end of today's class. We've been able to cover visualization generally, right? At the end of this class, you're going to see something called anatomy of a figure. This material will show you anatomy of a figure. So it basically shows you the description of every aspect of a figure in Matplotlib. So you can look at it and just read it and see how it aligns with what we've done so far. All right. So that's basically it. So these are the codes. These are the examples that we have in the notebook for each of the charts, right? So you can see each of the code, each of the charts here. and all of that. So basically, um, this is just Matplotlib for you. All right, we've been able to do justice to that, but I quickly want to show you something. Once you create a chart, you can actually save it. All right, you can actually save a chart to your computer. So let's see, quickly end with that. So now that I've created this let's use this particular one. I've created this my bar chart. I can save it. I can come here and say plot.save fig, and then I will give a name and say maybe bar chart.png. Can use either PNG or JPG, but I advise you to always use PNG because it's the best format. So then run it. So automatically it saves it to your folder. If you come to your folder here, you can see that it has saved it here. So you see bar chart.png. If you open it, it's going to give you a picture. It's going to give you a picture. If we can wait for that to load, so you can see this is a picture. You can share the picture with anybody. It's a picture basically, right? So you can share it. So anything you do with Matplotlib in Python, you can save it and share it with anybody, right? You can just share it on social media or any place that you want to share. So there are a lot of things you can do with it, right? So you just need to be creative with your visualization, right? Once you've gotten your data, you can do what you want to do with Matplotlib. So the code to save your chart is plot.savefig. See it here. Plot.savefig, SAVEFIG, and the argument is the name. So it saves the figure, the current figure, this figure that you're plotting here. If you do this plot.savefig in another figure, it's going to save this scatter plot instead. But in this case, it's saving this bar chart, and the name you included in the argument is the name it will save it as, and it will save it in the same directory, in the same folder in which this particular notebook is in. All right, so that is just it for Matplotlib. So we are going to be calling it a day here. Unfortunately, today I will not be taking live questions because I'm just going to take two questions, right? My laptop is about dying now, so I need to plug it. So, but I'm going to see if I can take 2 or 3 questions before we call it a day. All right. So if you have any question, just indicate, and all right. Okoli Precious, please ask your question. You're on mute now. Okoli Precious, you're on mute. Go ahead and ask your question. Please be fast about it.
Okay, sir, it's about yesterday. I made a complaint which asked me to come to your DM, and up to now, you've not replied.
Yeah. It's still. I'm still going to sort that out. I've not been able to settle down since then, so that's not an issue. I'm going to resolve those issues. All right.
All right,
Thank you. All right, James, please ask your question quickly.
Good evening, sir, and good evening everyone in the class. And my question is this: like, we had in data frame where we were opportune to, like, with the code we add columns and rows. So here in the meta, oh God, I don't know what was this thing we are doing today. So, sir, how can we add bar to charts?
You can't add bar. The bar is a
Yes,
representation of your data, right? If your data has 4 bars, 4 categories, it's 4 bars you will get. If your data has 5 categories, you have 5 bars. If you want to add a bar, then you need to add another category to your data. So the visualization is a representation of your data. It shows you what your data is, all right? It doesn't show you more than your data or less than your data. As your data is, that is how your V's would be. You can't add bar. The only thing you need to do is just to add data, like extra data or extra category, and it will be reflected in your visualization. All right.
Okay. All right. Thank you.
Okay. So I'm going to take the last question from Kuma. So please quickly ask your question. Quickly. Thank you.
Okay, good evening, sir.
Yeah, good evening.
Um, like I want to know, like when you are writing a dictionary, so when you are inputting the values for your this thing that needs to be in a string, so is there a way that you can just make a function that will put it in a string and all the commas together instead of just typing it one by one like that? Because most of the times I always make some silly mistakes with that.
Everything cannot be automated. You understand? You need to, because the renaming of columns, for example, you just have to do that manually, right? Unless you want to get the columns from the column names and then iterate over the list and then rename it. But things like that, you just have to do them manually, all right? But you can actually go over the column names, extracting it from df.columns, and then say df.columns square bracket 0 for the first one, square bracket 1 for the second one, like that, and then get the column names and change it. But like you just need to be able to do these things. Like it's not everything that can be automated, in that should be automated rather. All right. So I don't know if I get your question, but if I didn't, you can just point it
Yeah,
out
that is the
in the.
question.
All right. Thank you very much. So
Okay,
I think
thank you
that
so
that
much.
will be it for now. Any other question? Okay. George, you have a question. Please be fast. Please be fast. Quick one. Quick one. You're on mute now. Quickly ask your question, George. All right, so I think we're just going to call it a day now. Any other questions should come to the Q&A section. We've actually exceeded time, so we're going to be calling it a day now. The recording will be made available this night, hopefully, and the materials will also be made available. So thank you very much for your time and your attention. I hope this was a very interesting class. Please just drop what you learned from today's class as usual, and I'm definitely going to go over it and just interact with you guys and react to them. All right. Thank you very much once again, and enjoy the rest of your day.